In modern infrastructure, identity isn't just about people. Engineers need access to systems, but so do CI/CD pipelines, automated jobs, and the workloads that power your applications. Often these systems hold elevated root-level privileges to critical infrastructure. Attackers took note of this according to the 2025 Data Breach Investigation Report, which states the percentage of hacks leveraging third-party systems, including CI/CD systems, GitHub Actions, and third-party SaaS, doubled from 15% to 30% in 2025. How do we make sure automated systems authenticate securely with credentials that can't be stolen, shared, and abused? Humans can respond to prompts and MFA challenges. Machines can't. They operate in a non-interactive mode, running processes for hours or even days. That's why Teleport extends identity beyond humans, giving machines and workloads their own short-lived and, when possible, device-bound and rotated, cryptographically verifiable identities that can't be easily stolen or shared by hackers. Teleport authenticates, authorizes, and audits every interaction, whether it's taken by a CI/CD job or a person. In this video, we'll look at how Teleport handles non-human identities. First, how Teleport grants machines and workloads access to resources enrolled in Teleport, and second, what we call universal identity, which is about issuing short-lived, SPIFFE-compatible identities that extend trust beyond Teleport itself. Let's get started. So machines like CI/CD pipelines, vulnerability scanners, or configuration tools often connect to infrastructure using long-lived secrets like SSH keys or API tokens. These keys can be easily stolen. All it takes is for you to do, well, nothing. As in this recent supply chain incident involving a compromised TJ Actions GitHub action, pipelines could have their credentials exposed just by running an everyday build. I mean, with a compromised personal access token that has write access, as in the previous example, the attacker's code runs inside your pipeline and can read anything the runner has access to. Environment variables, files, tokens. Just cat that secret to a file, commit, and push for the world to see. What Teleport does is replace those static credentials, those environment variables, with short-lived certificates that prove a machine's identity every time it connects. Say a step in your GitHub action needs to retrieve a list of all the servers you have enrolled in the Teleport cluster, and then just for demonstration, SSH into each one and get a hostname and uptime. To do this, you don't need to generate some static, overprivileged Teleport API key to store as an environment variable in GitHub. Instead, the workflow presents a short-lived GitHub OIDC ID token to prove who it is. Teleport verifies that token against your join token's GitHub rules, like your repo, owner, or workflow, and can issue a short-lived Teleport certificate to successfully run the CLI command to list the servers in Teleport in SSH. No static secrets in the process. And there are other purpose-built actions available too. For example, to fetch a short-lived kube config for Teleport managed Kubernetes clusters, or to get short-lived app credentials for internal applications. And these run right in the workflow thanks to tbot, a lightweight Teleport agent that can run wherever your automation lives, on AWS, GitHub Actions, a Linux host, or even inside a Kubernetes cluster. tbot authenticates through a platform's trusted join mechanism, whether that's an AWS IAM role, a Kubernetes service account, or TPM-based host attestation to request short-lived X509 certificates from Teleport's auth service. tbot can then generate artifacts like SSH, database, or Kubernetes configs, letting automation tools connect seamlessly to Teleport managed resources. And these bots are treated as first-class identities. Access is enforced by Teleport roles, every action is recorded in the audit log, and identities expire automatically, ensuring no static secrets remain. Let's look at a practical example using Ansible. Normally with Ansible, you would deploy an SSH public key to every server you want to manage, which quickly can become a nightmare at scale. But in Teleport, each enrolled server trusts certificates signed by Teleport's built-in certificate authority, so our Ansible runner doesn't need to push keys everywhere. I have a playbook here that simply runs apt update on my Teleport enrolled servers. And when I run it, tbot retrieves short-lived credentials and then writes an open SSH profile, identity files, known hosts, and an SSH config snippet. Ansible then uses that config to connect and run the commands. And each connection is authorized through Teleport's access policies and logged in the audit trail. So our Ansible bot simply presents a short-lived certificate issued by Teleport, which the servers recognize as a valid identity. But automation is only half the story. Inside your infrastructure, your services are constantly talking to each other across clusters, clouds, and environments, and every one of those connections needs to be authenticated no matter where they run. Well, Teleport extends identity beyond human users and automation to your workloads themselves, issuing short-lived, SPIFFE-compliant certificates that let services prove who they are whenever they communicate. This replaces static tokens and shared secrets with verifiable, renewable identities that are trusted everywhere. For example, workloads can use these identities in authenticating workloads to third-party APIs on platforms like AWS, GCP, or Azure, issuing X509 certificates for mutual TLS between workloads as part of a zero-trust strategy, or enabling secure service-to-service authentication within your infrastructure itself. And what makes this possible is SPIFFE, or the Secure Production Identity Framework for Everyone. SPIFFE defines a common identity format any system can understand, and Teleport is able to issue certificates that follow this standard. That means workloads can use SPIFFE-compatible identities issued by Teleport to authenticate directly with one another using mutual TLS without relying on the Teleport proxy or being directly managed by Teleport. Because SPIFFE is an open standard, trusted by systems like Istio, Envoy, and Spire, Teleport-issued identities interoperate seamlessly across your environment. In short, SPIFFE provides the language of trust, and Teleport provides the trust itself, issuing, rotating, and managing these short-lived certificates so your workloads can securely authenticate wherever they run. So in conclusion, whether it's automation connecting through Teleport to manage infrastructure or workloads securely communicating across clusters and clouds, Teleport provides the foundation of trust, issuing, rotating, and auditing every identity through the same unified system. You can try out Teleport for free today for 14 days at goteleport.com/signup. Thank you for watching.